Let us now look at how we can transpose arrays using NumPy. The transpose operation reverses the order of an array. It switches the rows to the columns and vice versa. This is only true in cases of a two-dimensional array. When it comes to a multi-dimensional array, the transpose operation moves the data from one axis to the other in the order specified in the transpose method. I'll walk you through some of the examples which I have for multi-dimensional arrays such that this idea is concrete. When we are looking at a two-dimensional array, here I have an array of 50 elements which is further segregated into 5 rows and 10 columns. Here is the array. If I call the np.transpose function on the array X, it simply changes the rows to the columns and columns to rows. In the original array, the first column, which is 0, 10, 20, 30, and 40, now become the first row for the transposed array. The second column, 1, 11, 21, 31, and 41, now form the second row of the transposed array, and so on. The same can also be done using the dot t only for NumPy arrays. Now let's move on to a three-dimensional array to get a better understanding of how transpose function works. Here I have an array of 60 elements which is comprising of 4 rows and 5 columns divided into 3 batches. Simply calling the transpose function on the array itself reverses the order in which the array was originally present. The rows, the batches now become the columns, the rows stay the same, and the columns now become the batches. This can be interpreted using axes. The 0th axis represents the number of batches, which in this case is 3. The first axis represents the number of rows, which in this case is 4. And the second axis represents the number of columns, in this case 5. Once we call the transpose function on a three-dimensional array like such, what happens is that the batches now become the columns, the rows stay the same, and the columns now become the batches. How you can interpret this input is as such. Let us first look at the columns. Since 0 is now typecasted as 2, let us now look at the column as at the second axis, which is the column. We see 0, 20, and 40. This now becomes the first row. 5, 25, and 45, which becomes the second row, and so on. As we are done processing the first column, we shift to the new column, 1, 21, and 41. But in this case, we now go to a new batch. This can also be interpreted by looking at the shapes. The shape of the original array was 3, 4, and 5. And if we reverse it, it becomes 5, 4, and 3. So once you have an idea of the shape and the axis in which we are to swap the elements, you can get an understanding of how a transposed array would look like. Moving on to another example, this is again our original array, and this is the transposed array. I am transposing this array onto these axes. In this case, I want the batch axis to stay the same. I want the column axis to come in place of the row axis, and the column axis now swaps with the row. So in this case, the columns basically represent the rows, and the rows are now seen as columns. The first row, 0, 1, 2, 3, and 4, now becomes the first column. The second row, 5, 6, 7, 8, and 9, now becomes the second column. Once we are done processing this batch, we move on to the second batch. We look at 20, 21, 22, 23, and 24, which now represents the first column of the second batch. In this case, the number of batches stay the same because the axis 0 stays as where it was. And the only difference is in the axis 2 and 1, which is swapped now. 3, 5, and 4, which was originally 3, 4, and 5. Let us look at another example. We have a same original array, and this is the transposed array. We want to transpose this array on the axis 1, 2, and 0. So this should be the new order of the new transposed array. So simply looking at the shape, we can first say that the first axis, which is 4, now comes at the axis 0. The second axis, which was 5, now becomes the first axis, and the 0th axis, which was 3, now takes. Let us look at another example. Here we have the original array comprising of 60 elements, and here is the transposed array. Let us first look at the shapes of this array before we further drill down into the output. The original shape was 3, 4, and 5, and we want the shape now to be take the axis 1, 2, and 0. The first axis, which was 4, comes first. The second axis, which was 5, now comes second, and the 0th axis now comes third, which was 3. Let us now look at the output. Since we are looking at the rows first, we will now process the first row for each batch from the original array. 0, 1, 2, 3, and 4 now form the first column. The first row of the second batch, 20, 21, 22, 23, and 24, now become the second column of the first batch in the transposed array. The first row of the third batch, 40, 41, 42, 43, and 44, now becomes the second column of the transposed array. Once we are done processing the first rows for each batch, we can now look at the subsequent rows. 5, 6, 7, 8, and 9 now form the first column for the second batch of the transposed array. 25, 26, 27, 28, and 29 becomes the second column, and 45, 46, 47, 48, and 49 becomes the third column of the second batch. In this case, in such a way, we can now traverse through the entire matrix and we get the resulting transposed array.